One of the top things that I get asked about is AutoML. In this two-part video, let's try using AutoML Vision to build and deploy a machine learning model that recognizes different types of chairs, along with a few other items sprinkled in for good measure. We're doing it all, from the raw data collection all the way to serving the model, and everything in between. Welcome to AI Adventures, where we explore the art, science, and tools of machine learning. My name is Yufeng Guo, and on this episode, we'll explore AutoML Vision, currently in alpha, and get our data into the right format as an input. In part 2, we'll use this data to build a model to detect what style of chair is in a picture. One of the things that makes AutoML so compelling is having a custom model. Existing models and services like the Vision API have no problem recognizing that these pictures have chairs in them. But what if you made your own chairs and you needed a way to catalog the various brands of different chairs in your inventory? Wouldn't it be nice to be able to use a custom Vision API, so to speak, which recognizes your particular chairs? That's what we're going to try to do with AutoML Vision. AutoML Vision takes as an input lots and lots of labeled photos. So get your camera out and start snapping pictures. How many pictures, you ask? Well, ideally you'd have hundreds of pictures per object. That would be good. And then once you get tired of clicking that shutter option, perhaps you'll try doing what I did to get lots and lots of pictures. To make it easier to capture data for AutoML, I chose to gather my training data by capturing videos of the chairs and then using the tool FFmpeg to extract out those frames. I've gone out over to the Google Sunnyvale campus. I took some videos of a variety of different outdoor chairs. I'll also took some video of the tables they were positioned around, as well as a bike, just to make things a little more interesting. Let's take a look at some of that footage now. Here we have some chairs of different shapes, styles, and colors. No video is greater than 30 seconds in length, and we have a short clip of a table and another of a bike. That's the data that we will be working with. The end state that we want is a CSV file that has one row per image and two columns. The first for the location of the image in Google Cloud Storage, and the second for the label like red chair or table or blue chair. To make it easier to organize, I placed each video in its own folder. So then we can run FFmpeg on each video file in turn within those folders. That way, once the frames are extracted out, you'll have one folder per label filled with images of just that label. This is a handy way to organize your images and data, and it's simpler than having one massive folder of all the images intermingled. Next, we can upload the images to Google Cloud Storage using gsutil, replicating our folder structure of one folder per label. Now it's time to get to work, creating a CSV file that lists the path and label for each image I wanted to include in my dataset. Now, there's lots of ways to accomplish this, but I chose to spin up a local Jupyter notebook and create a pandas data frame that gets exported as a CSV file. Let's walk through that code now. Okay, so here we are in our Jupyter notebook. I've imported OS and pandas so we can work with the file system and load up pandas that we can use that to export our CSV. I've listed out all the folders that I want to use to pull in the data, and I've listed this out here explicitly because perhaps in a different scenario, I might choose to use just a subset of these folders to create a different training set. So then we have a setup here to create a dictionary of our folder name and then a mapping to an array of all of our files for that folder. And so to do that, first I'm going to create an array of arrays of just all of those file names. Each inner array is all the file names of one folder, and the outer array is just for each folder. And so here we have, we're listing through all the files in a folder, so our data folder's here, and we'll wrap that in an array so that we can capture that. And so we can see here I've printed a sample of one value, one image from each of the folders, and we can see that they're all different. So it looks like we're in good shape. And so we can take those two, our folder names and all our file names, and zip them together, pass them to create a dictionary. Using that and our base Google Cloud Storage path, we can glue these two together because we want to prepend the GCS or Google Cloud Storage path in the final output. So what we want is something like this, where we have the Google Cloud Storage directory path with all the way out to the .jpeg name, and then a comma, and then the name of the label. So in this case, maybe we have a comma and then chair black, like so. And so to do that, we'll loop over the entire dictionary. And for each file in the array of file names in that dictionary, we will put together the base Google Cloud Storage path along with the folder name and file name, as well as that label. So now what we have with us here is an array of pairs. Each pair has that path and the label. Okay, so we can take this array and just pass it straight into a data frame. Pandas accepts that format to create new data frames from scratch, and our data frame looks exactly as we'd expect. We've got all our paths and all our labels. Now we're ready to export to CSV. In this particular case, we want to export such that we use index equals false and header equals false. This is important and can really trip you up if you forget to do this, because if you leave the defaults, which are index true and header true, the outputted CSV file will have a header row of 0 and 1. And moreover, it will have an index column that comes before everything else, which is just going to be your 0, 1, 2, 3, 4, 5. So we don't want any of that. We just want the path to the file and the label and nothing else. So we use index false and header false. So if you organize your folder structure the same way that I have mine, you can take this notebook and with a couple of minimal changes, adapt it for your use case as well. So I'll definitely publish this notebook and link to that down below in the video description. All right, so now we have a CSV file describing the location and label for all the images in our dataset. We're ready to train our model. Join me in part 2 of this episode, and we'll see just how well this model can perform. Thanks for watching this episode of Cloud AI Adventures, and if you enjoyed it, hit that like button down below, and be sure to subscribe to get all the latest updates right when they come out. And while you head over to part 2 of this video, I'm gonna eat this apple.